The solar system is our home, but it is just one among billions in the universe. The vastness of space holds countless other star systems. Some may be like ours, with planets orbiting a central star. Others may be very different, with multiple suns or planets unlike anything we have seen. Scientists have been searching for exoplanets, planets outside our solar system. They want to know how common systems like ours are. They also want to find out if other planets could support life. The universe is full of mysteries, and our solar system is just one small part of a much bigger picture. For a long time, people believed the solar system was special. It was the only system we knew. The sun, with its planets and moons, seemed like a perfect balance. But as technology improved, we started to discover other planets around distant stars. Now we know that solar systems are everywhere. Almost every star we study has planets around it. Some are small, like Earth. Others are massive gas giants, like Jupiter. Some stars even have many planets, just like our sun. But is our solar system unique? Scientists have found that many star systems are different from ours. Some have planets much closer to their star than Mercury is to the sun. Others have gas giants in strange orbits. Some systems have 2 or more stars. Our solar system is stable. The planets follow nearly circular orbits, which helps create a balanced environment. Many other systems seem more chaotic. Some planets have extreme orbits that bring them close to their star and then far away. Some systems have planets so close together that they might collide in the future. The arrangement of our solar system may have helped life develop on Earth. Jupiter and Saturn act like giant shields, protecting Earth from many comets and asteroids. If our solar system had formed differently, Earth might have been hit more often by space rocks. This could have made it harder for life to survive. The presence of a large moon also helped stabilize Earth's rotation. Without it, our planet's climate might have changed too much for life to evolve. Our sun is also unusual. It is a G-type main sequence star. These stars are common, but they are not the most common. Most stars in the galaxy are red dwarfs, which are smaller and cooler than the sun. Many red dwarf stars have planets, but these planets are often very close to their star. This means they may be bombarded with radiation, making it hard for life to exist. Some scientists believe that Earth-sized planets around red dwarfs could still have life, but it would be very different from what we know. Now let's discuss about exoplanets and other star systems. An exoplanet is a planet outside our solar system. The first exoplanet was discovered in 1992. Since then, thousands have been found. Some are rocky like Earth, others are gas giants like Jupiter. Some orbit very close to their stars, completing a year in just a few days. Others are far away in cold outer regions. Scientists use different methods to find exoplanets. The transit method looks for dips in a star's brightness when a planet passes in front of it. The radial velocity method detects tiny wobbles in a star's movement caused by a planet's gravity. Both methods have helped us learn more about distant worlds. Some exoplanets are in the habitable zone. This is the area around a star where conditions might allow liquid water to exist. Water is essential for life as we know it. Scientists believe that planets in this zone have the best chance of supporting life. Some exciting discoveries include Kepler 452b, a planet that is similar to Earth, and TRAPPIST-1, a system with 7 rocky planets. 3 of these planets are in the habitable zone. Not all exoplanets are like the ones in our solar system. Scientists have found hot Jupiters, which are massive gas giants orbiting very close to their stars. They have also found super-Earths, which are larger than Earth but smaller than Neptune. Some planets seem to be made entirely of water, while others may have thick atmospheres of gas. The diversity of exoplanets shows that solar systems can form in many different ways. There are also rogue planets, planets that do not orbit any star. These planets were likely ejected from their original systems. They float through space, cold and dark. Some scientists believe rogue planets could have underground oceans protected by thick ice layers. If so, they might even support life deep below the surface. Moving to our next topic, which is theories about the possibility of other habitable systems. One of the biggest questions in science is whether we are alone in the universe. If our solar system is not unique, could there be other planets with life? Scientists have been searching for signs of life beyond Earth. They study exoplanets to see if they have the right conditions. They also listen for signals from intelligent civilizations. The Drake equation is a formula that estimates how many civilizations might exist in our galaxy. It considers factors like the number of planets, the chances of life forming, and how long civilizations might survive. Some scientists believe there could be many intelligent civilizations. Others think life might be very rare. So far, we have not found any clear signs of alien life. Some researchers believe life could exist on exomoons, moons that orbit exoplanets. In our solar system, moons like Europa and Titan have conditions that might support life. If similar moons exist around exoplanets, they could also have life. There is also the rare Earth hypothesis. This idea suggests that Earth is special and that life is very rare. It argues that many factors had to be just right for life to exist here. A stable star, a large moon, a magnetic field, and the right kind of atmosphere all helped life survive. If one of these things had been different, Earth might not have developed life. This could mean that habitable planets are very rare. On the other hand, the mediocrity principle suggests the opposite. It says that Earth is not special. If life developed here, it should have developed elsewhere too. There are billions of stars and planets. The conditions for life might be common. If that is true, there could be many habitable planets in the universe. Let's discuss about what the future holds. Technology is improving. Scientists are building better telescopes to study exoplanets. The James Webb Space Telescope can look at distant planets and analyze their atmospheres. Future missions might find signs of life. We may discover planets with oxygen, water, or even chemical signals that suggest living organisms. Humans may one day visit other star systems. Right now, the distances are too great. The closest star, Proxima Centauri, is 4.24 light-years away. With current technology, it would take thousands of years to reach it. But in the future, new propulsion systems could make interstellar travel possible. If humans survive long enough, they may leave the solar system. They could travel to exoplanets and build colonies. The solar system is just the beginning. The universe is full of possibilities. We may one day find other planets like Earth. We may even find life beyond our world. The search continues, and every new discovery brings us closer to understanding our place in the universe. Earth does not exist in isolation. It is part of the solar system, surrounded by planets, moons, asteroids, and comets. The movements of these celestial bodies affect Earth in different ways. Some effects are small, while others have shaped the planet for billions of years. The Sun plays the biggest role in Earth's existence. Without it, life would not be possible. Other planets also have an influence, sometimes directly, sometimes in ways we do not notice. People have observed these effects for thousands of years, often creating myths and stories to explain them. Today, scientists study how the solar system affects Earth, helping us understand our place in the universe. Now let's discuss how planetary movements affect Earth's climate. The movement of planets can influence Earth's climate over long periods. One of the most important effects comes from changes in Earth's orbit. Our planet does not move in a perfect circle around the Sun. Instead, its orbit changes shape over thousands of years. Sometimes it is nearly circular. Other times it becomes more stretched. This change affects how much sunlight Earth receives, which can lead to ice ages or warm periods. Another important factor is the tilt of Earth's axis. Right now, Earth is tilted at about 23.5 degrees. This tilt is what causes seasons. When one hemisphere is tilted toward the Sun, it experiences summer. The other hemisphere, tilted away, experiences winter. But the tilt does not stay the same forever. Over thousands of years, it changes slightly. This affects climate by changing how much sunlight reaches different parts of the planet. Even the wobble of Earth's axis plays a role. This wobble, called precession, happens slowly over 26,000 years. It causes shifts in weather patterns and the timing of seasons. Over time, these small changes add up, leading to big differences in Earth's climate. Other planets also have an influence. Jupiter and Saturn are massive. Their gravity affects the shape of Earth's orbit. When their positions change, Earth's orbit becomes more or less stretched. This also changes the amount of sunlight Earth receives. These long-term changes are known as Milankovitch cycles. They help explain past ice ages and warm periods. Scientists study these cycles to predict future climate changes. Asteroids and comets also affect Earth's climate. If a large asteroid hits Earth, it can create huge changes. Dust and debris from the impact can block sunlight, causing temperatures to drop. Some scientists believe an asteroid impact caused the extinction of the dinosaurs. A similar event today could have serious consequences for life on Earth. Next, we will discuss the importance of the Sun in sustaining life. The Sun is the most important object in the solar system. It provides heat and light, making life possible on Earth. Without the Sun, Earth would be a frozen, lifeless world. The Sun's energy drives weather patterns, ocean currents, and the growth of plants. Sunlight is essential for photosynthesis. Plants use sunlight to create food. This food supports all life on Earth. Without plants, animals would not have anything to eat. Even creatures in the deep ocean depend on the sun. They feed on material that comes from the surface where sunlight reaches. The sun also affects Earth's atmosphere. It creates wind and ocean currents. Warm air rises while cool air sinks. This movement creates weather patterns. The sun's energy also causes evaporation, forming clouds and rain. Without these processes, Earth's climate would be completely different. The sun is not always stable. It sometimes releases bursts of energy called solar flares. These flares send charged particles toward Earth. When they reach our planet, they can create beautiful lights called auroras, but they can also cause problems. Strong solar storms can damage satellites, disrupt radio signals, and even affect power grids on Earth. Scientists monitor the sun to predict these events. Over billions of years, the sun has slowly changed. It is getting hotter and brighter. In the distant future, it will become so hot that Earth will no longer be habitable, but that is billions of years away. Right now, the sun continues to support life, making Earth a special place in the solar system. Now let's discuss planetary alignments and their myths. Throughout history, people have noticed the movement of planets in the sky. Sometimes planets appear to line up in a straight line. This is called a planetary alignment. These alignments do not happen often. When they do, they can look amazing, but they do not have a big effect on Earth. Many ancient cultures believed that planetary alignments had special meanings. Some thought they predicted important events. Others believed they could cause disasters. Even today, some people think alignments can affect human behavior, but scientists have found no evidence for this. One famous myth is that planetary alignments cause earthquakes. Some people believe that the gravity of aligned planets pulls on Earth, causing natural disasters, but this is not true. The gravity of planets is very weak compared to the gravity of the Moon and Sun. Even when all the planets align, their combined pull is not strong enough to affect Earth in any noticeable way. Another myth is that alignments cause big changes in the solar system. Some people believe that during an alignment, Earth could be pulled out of its orbit, or that something unusual could happen to the Sun. But this is also false. Planetary alignments are just interesting to look at. They do not change how the solar system works. One of the most famous planetary alignments happened in 2000. Many people thought it would cause disasters, but nothing unusual happened. Another alignment will occur in 2040. When 6 planets will be visible close together in the sky. Scientists and space enthusiasts look forward to these events because they offer a great chance to observe planets. Even though alignments do not affect Earth, they are still fascinating. They remind us that we live in a system full of moving objects. Watching the planets move across the sky connects us to ancient civilizations who did the same. While myths and stories have faded, the beauty of the solar system remains. The solar system influences Earth in many ways. Changes in Earth's orbit affect climate over long periods. The sun provides energy, making life possible. Planetary alignments have fascinated people for centuries, even if they do not have real effects. Studying these influences helps us understand the past and prepare for the future. Earth is part of a larger system, constantly changing and evolving. Scientists continue to explore these connections, revealing more about our place in the universe. The sun is the center of our solar system. It is a star that provides heat and light to all the planets. Without the sun, life on Earth would not exist. The sun's energy supports all life on Earth and shapes the weather, climate, and even the seasons. The sun is made of hot gases and is mostly composed of hydrogen and helium. It is huge, with a diameter of about 1.4 million kilometers, which is more than 100 times the size of Earth. The sun is so massive that it accounts for about 99.86% of the total mass of the solar system. Everything in the solar system, including the planets, asteroids, comets, and even dwarf planets, all orbit the sun. The sun's gravity is what holds the solar system together. The sun is not just a light source. It is a powerful force. It releases an incredible amount of energy. Every second, the sun produces about 4.2 million tons of energy. This energy comes from the process of nuclear fusion happening at the sun's core. In this process, hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the form of light and heat. This is what powers the sun and allows it to shine for billions of years. The sun has been shining for about 4.6 billion years, and it is expected to continue for another 5 billion years. But even though the sun is stable now, it won't always be. In the future, it will go through several stages of change. Eventually, it will run out of hydrogen fuel in its core and begin to fuse helium. This will cause the sun to expand into a red giant. During this phase, the sun will become much larger and will likely engulf the inner planets, including Earth. After this, the sun will shed its outer layers, leaving behind a white dwarf. The white dwarf will gradually cool and fade over billions of years. Despite its size and power, the sun is only a middle-aged star. Stars come in different sizes and types. The sun is considered a G-type main sequence star, which is one of the most common types in the universe. There are much larger stars like supergiants and much smaller stars like red dwarfs. The sun is not as large as the supergiants, but it is much larger than red dwarfs. The sun is made up of several layers. The outermost layer is the corona. The corona is the sun's outer atmosphere, and it is surprisingly very hot, hotter than the sun's surface. The temperature in the corona can reach millions of degrees, while the surface of the sun is only around 5,500 degrees Celsius. The reason for this temperature difference is not fully understood, but it is one of the biggest mysteries in solar science. Beneath the corona is the chromosphere, a thin layer of gas. It is not as hot as the corona, but still reaches temperatures of about 10,000 degrees Celsius. The chromosphere is where solar flares and prominences occur. Prominences are massive loops of hot gas that extend from the sun's surface into the corona. They can last for days and are often seen as bright, arching shapes during a solar eclipse. The next layer is the photosphere, which is the visible surface of the sun. This is what we see when we look at the sun with our eyes or through a telescope. The photosphere is not solid but made of gas. It appears solid because the gas is so dense that it blocks the view of deeper layers. The temperature of the photosphere is about 5,500 degrees Celsius. Beneath the photosphere is the convective zone, where energy is transferred outward through convection. This is a process in which hot gases rise toward the surface, cool down, and then sink back toward the sun's interior. The convective zone is responsible for creating the sunspots, dark, cooler areas on the sun's surface. These spots are often grouped together and follow an 11-year cycle, which affects the sun's activity. At the core of the sun, the temperature is incredibly high, around 15 million degrees Celsius. This is where nuclear fusion occurs. The core is the most important part of the sun. Without it, the sun would not shine. The core produces all the energy that fuels the sun. The energy produced by fusion in the core takes thousands of years to travel outward to the surface, and then it is radiated into space as light and heat. The sun has a powerful effect on the entire solar system. Its gravity keeps the planets in orbit. Without the sun's gravity, the planets would drift off into space. The sun's energy is also responsible for the seasons on Earth. As Earth orbits the sun, the tilt of its axis causes different parts of the planet to receive more or less sunlight. This leads to the changes in temperature and weather that we experience as seasons. The sun also influences the space around Earth in a region known as the heliosphere. The heliosphere is a bubble of charged particles that the sun sends out into space. This stream of particles is called the solar wind. The solar wind can affect the planets, especially Earth. It can interact with Earth's magnetic field, creating auroras, or the northern and southern lights. These beautiful light displays occur when charged particles from the solar wind collide with atoms in Earth's atmosphere. The sun's activity also has a direct impact on technology here on Earth. Solar flares and coronal mass ejections, or CMEs, can release large bursts of energy that travel through space. These bursts can affect communication satellites, GPS systems, and even power grids. In extreme cases, solar storms can cause massive damage to our technology. Scientists closely monitor the sun's activity to predict solar storms and protect our technology. Studying the sun is critical for understanding not just our solar system, but other star systems as well. The sun is just one of billions of stars in the Milky Way galaxy. By learning how the sun works, scientists can learn more about other stars and their potential to support life. The sun's life cycle, from its birth to its eventual death as a white dwarf, mirrors the life cycles of other stars. One of the most exciting aspects of solar science is the study of solar system formation. The sun formed from a giant cloud of gas and dust that collapsed under its own gravity. As the sun formed, the leftover material gathered to form the planets. By studying the sun's composition and behavior, scientists can learn about the processes that shaped our solar system. The sun may be just one star, but it is vital to our existence. It gives us light, heat, and energy. It affects the weather, powers the Earth's ecosystems, and drives space weather. Without the sun, there would be no life on Earth. It is the center of our solar system, and its importance cannot be overstated. Moons are an important part of the solar system. They orbit planets and influence their behavior. Some moons are small and irregular, while others are as large as planets. Scientists study moons to learn more about planetary systems. And some moons may even have the right conditions for life. Earth has one moon, but other planets have many. Jupiter and Saturn have more than 80 moons each. Even dwarf planets have moons. Pluto has 5 known moons. The largest is Charon. And interestingly, some asteroids also have small moons. Moons come in different sizes and shapes. Some have smooth surfaces, while others are covered in craters. Some have active volcanoes, and others have icy oceans beneath their surface. Earth's moon is the brightest object in our night sky. It has been important to humans for thousands of years. It affects Earth's tides and even the length of our day. The moon formed billions of years ago. Scientists believe a large object hit Earth, and this impact sent debris into space. Over time, the debris came together to form the moon. This, folks, is called the giant impact hypothesis. The Moon is about 384,000 kilometers away from Earth. It is about 1/4 the size of Earth. Because of its size and gravity, it influences Earth's oceans. The Moon's gravity pulls on Earth's water. This causes ocean tides. When the Moon is overhead, the water rises. This is called high tide. When the Moon moves away, the water lowers. This is called low tide. The Moon also slows down Earth's rotation. Billions of years ago, Earth spun much faster, but the Moon's gravity pulls on Earth, slowing it down. Because of this, days on Earth have become longer. Scientists think that in the distant future, Earth's rotation will slow even more. The Moon has no atmosphere. This means there is no air to breathe. There is also no protection from space radiation. Because of this, temperatures on the Moon can be extreme. It can be very hot during the day and very cold at night. The Moon's surface is covered in regolith, a layer of dust and small rocks. There are also many craters caused by asteroid impacts. The Moon has been explored by humans. In 1969, Apollo 11 landed on the Moon. Astronauts Neil Armstrong and Buzz Aldrin walked on the surface. They collected rock samples and conducted experiments. Since then, many missions have studied the Moon. Scientists have found evidence of water ice at the Moon's poles. This could be important for future space missions. Jupiter has 79 known moons. Some are large and icy, others are small and rocky. The 4 biggest moons are called the Galilean moons. They are Io, Europa, Ganymede, and Callisto. These moons were discovered by Galileo in 1610. Io is the most volcanic world in the solar system. It has hundreds of active volcanoes. Lava flows cover its surface. The intense heat comes from Jupiter's gravity. As Io orbits Jupiter, it is pulled and stretched. This creates heat inside Io, causing volcanic activity. Europa is one of the most interesting moons. It has a thick, icy crust, but beneath the ice there is a deep ocean. Scientists believe this ocean might contain life. The heat from the Moon's interior could keep the water liquid. Life on Europa would be very different from life on Earth. But some bacteria on Earth live in deep oceans without sunlight. This gives hope that life might exist on Europa. Ganymede is the largest moon in the solar system. It is even bigger than Mercury. Ganymede has a magnetic field, the only moon known to have one. It also has layers of ice and possibly an underground ocean. Callisto is the most cratered moon in the solar system. It is covered in impact marks from asteroids. Callisto may also have a hidden ocean beneath its surface. If so, it could be another place where life might exist. Saturn has 83 known moons. The largest is Titan. Titan is unique because it has a thick atmosphere. It is mostly nitrogen, like Earth's atmosphere. Titan has lakes and rivers, but they are not made of water. Instead, they are filled with liquid methane and ethane. The temperature is extremely cold, so water remains frozen. Some scientists think Titan might have the right chemistry for life. Another important moon of Saturn is Enceladus. It is covered in ice, but it has geysers that shoot water into space. This suggests there is a liquid ocean beneath the ice. The water contains organic molecules, the building blocks of life. Scientists have sent spacecraft to study Enceladus. They hope to learn more about its potential for life. Not all moons are large and round. Some are small and oddly shaped. Phobos and Deimos are the 2 moons of Mars. They are small and look like asteroids. Scientists think they were captured by Mars' gravity. Phobos is slowly moving toward Mars. In millions of years, it may crash into the planet. Deimos is farther away and is more stable. Pluto, once considered the 9th planet, has a large moon called Charon. Charon is so big that Pluto and Charon orbit each other like a double system. Charon's surface has deep canyons and icy plains. Scientists believe Pluto and Charon may have once been part of the same object before they separated. Moons play an important role in the solar system. They help us understand planets, gravity, and even the search for life. Some moons, like Europa and Enceladus, might have hidden oceans. Others, like Titan, have thick atmospheres. Each moon is unique and tells us more about the history of the solar system. Scientists continue to study moons using telescopes and spacecraft. In the future, missions might land on these moons and search for signs of life. Now we will discuss about comets, meteoroids, and cosmic debris. The solar system is not just made of planets and moons. It is full of smaller objects that travel through space. These include comets, meteoroids, and asteroids. Each of them is different, but they all come from the early days of the solar system. They can tell us how planets formed. Some of them also create beautiful events like meteor showers. Others can be dangerous if they hit Earth. Scientists study these objects to understand the past and to predict future events. Now, differences between comets, meteoroids, and asteroids will be discussed. Comets are icy objects that orbit the Sun. They come from the outer parts of the solar system. When they get close to the Sun, their ice turns into gas. This creates a bright tail that stretches across the sky. Comets have long oval orbits. Some take hundreds or even thousands of years to go around the Sun. Meteoroids are small pieces of rock or metal that float in space. They can be as small as a grain of sand or as large as a boulder. When a meteoroid enters Earth's atmosphere, it burns up. This creates a streak of light called a meteor. If a meteoroid is big enough to reach the ground, it is called a meteorite. Asteroids are larger than meteoroids. They are made of rock and metal. Most of them are found in the asteroid belt between Mars and Jupiter. Some asteroids have moons of their own. Unlike comets, asteroids do not have tails. Some asteroids may have been parts of planets that never formed. Comets have been observed for thousands of years. Some comets appear regularly, while others are seen only once. One of the most famous comets is Halley's Comet. It was named after the astronomer Edmund Halley. He studied records of past comets and noticed a pattern. He predicted that the same comet would return every 76 years. The comet was last seen in 1986. It will appear again in 2061. Another famous comet is Comet Hale-Bopp. It was one of the brightest comets in modern times. It was visible to the naked eye for 18 months. This made it one of the longest-lasting comets seen from Earth. Comet Shoemaker-Levy 9 was also important. It broke apart and crashed into Jupiter in 1994. The impact created huge explosions in Jupiter's atmosphere. This showed scientists what could happen if a large object hit a planet. Now let's talk about meteor showers and their origins. Meteor showers happen when Earth passes through the debris left by a comet. When the tiny particles enter our atmosphere, they burn up. This creates a beautiful display of shooting stars. Some meteor showers happen at the same time every year. One of the most famous meteor showers is the Perseids. It happens every August. The Perseids come from Comet Swift-Tuttle. The Geminids occur in December. They come from an asteroid called 3200 Phaethon. The Leonids happen in November. They come from Comet Tempel-Tuttle. Meteor showers can be predicted. Some are stronger than others. If Earth passes through a dense part of a comet's debris, the meteor shower is more intense. Sometimes thousands of meteors can be seen in one night. Moving to our next topic, which is the role of cosmic debris in shaping planets. Cosmic debris played an important role in the early solar system. When the solar system was young, space was full of dust and rocks. These pieces collided and stuck together. Over millions of years, they grew into planets and moons. Even today, debris still affects planets. Asteroids and comets have hit Earth many times. One of the most famous impacts happened 66 million years ago. A large asteroid crashed into what is now Mexico. This impact caused fires, tsunamis, and a massive dust cloud. It is believed to have caused the extinction of the dinosaurs. Small meteoroids enter Earth's atmosphere every day. Most burn up before reaching the ground. Larger ones can create craters. The Moon and Mercury are covered in craters because they have no atmosphere to protect them. Scientists study asteroids and comets to learn more about the solar system's history. Some space missions have visited these objects. The Rosetta mission studied Comet 67P. The OSIRIS-REx mission collected a sample from asteroid Bennu. These missions help scientists understand the materials that form the planets. Cosmic debris is a reminder of how active the solar system is. It has shaped planets in the past and will continue to do so in the future. Some objects may pose a threat to Earth. Scientists keep track of asteroids that could come close. They are developing ways to protect the planet from future impacts. Studying these objects helps us understand both the past and the future of our solar system. For a long time, people thought Earth was the only place with life. But as we explore space, we realize that life might exist elsewhere. Scientists are searching for signs of life in the solar system. They look for planets and moons that have the right conditions. They study extreme environments on Earth to understand where life can survive. The search for life is one of the biggest questions in science. If we find life beyond Earth, it will change everything we know. So what makes a world habitable? Life needs certain conditions to survive. Water is the most important. On Earth, all life depends on water. Scientists believe the same is true elsewhere. If a planet or moon has liquid water, it might support life. Other factors also matter. A stable temperature helps. If a place is too hot or too cold, life may not survive. An atmosphere is also important. It protects a planet and can help trap heat. The right chemicals like carbon and nitrogen are needed for building life. The habitable zone is the area around a star where liquid water can exist. Earth is in the Sun's habitable zone. Venus, on the other hand, is too hot. Mars is cold, but it is at the edge of the zone. Interestingly, some planets outside our solar system are in habitable zones as well. But life may not only exist in these areas. Some moons far from the Sun may have liquid water under their surfaces. These places could also be habitable. Now let's discuss about Mars. Mars is one of the best places to look for life. Long ago, it had rivers, lakes, and even oceans. Today, its surface is dry, but water still exists underground and at the poles. Some scientists believe microbes may live under the surface. Rovers like Perseverance and Curiosity are searching for signs of ancient life. They study rocks and soil for chemical clues. If Mars once had life, its fossils might still be there. Mars also has methane in its atmosphere. On Earth, most methane comes from living things. This raises questions. Is Mars producing methane through geological activity, or is it coming from tiny life forms under the surface? Future missions will try to find the answer. If we find life on Mars, it could mean that life is common in the universe. Now, let's discuss about Europa. Europa is a moon of Jupiter. It has a thick ice crust. Underneath, there is a deep ocean. This ocean is heated by the moon's core. Scientists believe that warm water vents at the bottom of Europa's ocean could support life. On Earth, similar vents exist at the bottom of the sea. These vents release heat and minerals. Strange life forms live around them. They do not need sunlight. If life can survive in deep oceans on Earth, it might survive on Europa too. The Europa Clipper mission will study this moon in the 2030s. It will look for signs of life. Scientists hope to send a lander in the future. It could drill through the ice and explore the ocean below. If we find even simple microbes on Europa, it would be a huge discovery. The next potential place is Titan. Titan is Saturn's largest moon. It is covered in thick orange clouds. It has rivers, lakes, and seas, but these are not made of water. They are made of liquid methane and ethane. Titan is extremely cold. Water is frozen solid. But scientists think life could exist there. It would be very different from life on Earth. Instead of water-based life, Titan might have methane-based life. This would be an alien form of life, unlike anything we know. NASA is planning a mission called Dragonfly. It will send a drone to explore Titan. The drone will fly from place to place, studying the surface. It will look for complex molecules that could lead to life. Titan is an exciting place because it is different from anywhere else in the solar system. If life exists there, it will change our understanding of biology. The next one is Enceladus. Enceladus is another moon of Saturn. It is smaller than Europa, but it also has an ocean under its ice. The Cassini spacecraft made a surprising discovery. It saw water plumes shooting into space from Enceladus. These plumes contain water, salt, and organic molecules. This means Enceladus has the ingredients for life. Scientists believe Enceladus has hydrothermal vents at the bottom of its ocean. Just like on Earth, these vents could support life. A future mission could fly through the plumes and test for microbes. If we find even tiny bacteria, it would prove that life can form in different environments. Now let's talk about extremophiles on Earth and what they teach us about alien life. On Earth, life exists in extreme places. Microbes live in boiling hot springs, deep under the ocean, and even inside rocks. Some bacteria survive in acidic lakes. Others live in the coldest parts of Antarctica. Some survive high radiation in space. These creatures are called extremophiles. Extremophiles show us that life is very adaptable. If life can survive in Earth's extreme environments, it might survive on other planets too. Some microbes can live without sunlight, using chemical energy instead. This is important because places like Europa and Enceladus have no sunlight under their ice. But if life can use chemicals from vents, it might still exist. Scientists have even found microbes that can survive in space. Some bacteria were sent outside the International Space Station. They survived for years. This suggests that life could travel between planets. If a meteor hit Mars and sent rocks to Earth, those rocks might have carried life. This idea is called panspermia. It suggests that life did not start on Earth but arrived from space. Let's end this topic discussing the future missions and initiatives to find life on other planets. New missions will search for life in the solar system. Rovers and landers will explore Mars. Probes will study Europa and Titan. Future spacecraft may collect samples and return them to Earth. Scientists are also searching for biosignatures, chemical signs of life. If we find the right molecules on another planet, it could mean life is there. If we discover life, even microbes, it will be a huge breakthrough. It will prove that life is not unique to Earth. This would mean life could exist throughout the universe. Scientists believe that if life started on Earth, it can start elsewhere too. The question is not if life exists, but where we will find it first. The search continues. Every new discovery brings us closer to answering one of the biggest questions. Are we alone in the universe? Humans have always been curious about space. We have sent robots and probes to explore the planets. But one big question remains. Can humans travel beyond Earth and live in space? Many scientists and engineers are working on this. The idea of people living on Mars or even further is exciting, but there are many challenges. Space is dangerous, the distances are huge, life support is difficult, and there are ethical concerns. Let's discuss the challenges of sending humans beyond Mars. Mars is the next big goal for human space exploration. NASA, SpaceX, and other space agencies are working on ways to send people there. But going beyond Mars is much harder. The main problem is distance. Mars is about 225 million kilometers from Earth on average. Even at its closest, it takes 6 to 9 months to reach. Any trip beyond Mars would take even longer. Jupiter is the next major planet. It is about 600 million kilometers away at its closest. A trip to Jupiter or its moons could take years. That means astronauts would need supplies for a long time. They would need food, water, and air. Recycling systems would have to work perfectly. Any failure could be deadly. Radiation is another problem. Space is full of radiation from the sun and distant stars. Earth's atmosphere protects us, but in deep space, astronauts would be exposed. Long-term radiation exposure increases the risk of cancer. It can also damage the brain and other organs. Scientists are working on better shielding, but it is still a big challenge. Gravity is also a problem. On Earth, our bodies are used to normal gravity. In space, astronauts experience microgravity. Over time, their muscles weaken, their bones lose calcium, their hearts have to work differently. On Mars, gravity is only 38% of Earth's gravity. On the Moon, it is even lower. On some distant moons or asteroids, there is almost no gravity. If humans want to live in space for a long time, they will need ways to deal with this. Communication is another issue. When astronauts go to Mars, messages will take minutes to travel between Mars and Earth. For missions to Jupiter or beyond, messages could take hours. This means astronauts would have to make decisions on their own. They could not rely on quick help from mission control. Technology will need to improve. Spaceships need better engines to travel faster. Life support systems must be more reliable. Spacesuits must be stronger and more flexible. Scientists are working on all of this. But right now, human travel beyond Mars is not possible. It may take decades before it happens. Let's talk about terraforming and space colonization theories. Many people dream of living on other planets, but space is not like Earth. There is no air to breathe. Temperatures can be extremely hot or cold. Radiation is everywhere. Gravity is different. To survive, humans would need to build enclosed habitats. These would provide air, water, and protection. Some scientists believe we could terraform planets. Terraforming means changing a planet to make it more Earth-like. One idea is to terraform Mars. Mars has a thin atmosphere, mostly made of carbon dioxide. If we could warm the planet, ice could melt and create liquid water. Some ideas include using giant mirrors to reflect sunlight onto Mars. Others suggest releasing greenhouse gases to trap heat. Over time, this could make Mars warmer. Some plants could grow and produce oxygen. But this process would take hundreds of thousands of years. Terraforming Venus is another idea. Venus is similar in size to Earth, but its atmosphere is thick and full of carbon dioxide. The surface is extremely hot. Some scientists suggest removing carbon dioxide from the atmosphere. Others propose floating cities high above the surface where the temperature is cooler. Jupiter's moon Europa is also interesting. It has a thick ice layer, but underneath there might be an ocean. Some believe humans could live in floating habitats on Europa. Similar ideas exist for Saturn's moon Titan. Titan has a thick atmosphere and liquid lakes made of methane. It is very cold, but with the right technology, humans might survive there. Building space habitats is another idea. Instead of living on planets, humans could build giant space stations. These stations could rotate to create artificial gravity. They could use solar power for energy. Scientists have proposed huge space cities like O'Neill's cylinders. These would be massive spinning structures with Earth-like environments inside. All of these ideas are exciting, but they're also difficult. Terraforming could take thousands of years. Space colonies would require huge amounts of resources. Some people wonder if it is even possible. Others question whether we should try at all. Space exploration raises many ethical questions. Should humans colonize other planets? Do we have the right to change other worlds? What if we find alien life? If we send humans to Mars or Europa, we must be careful. Scientists worry that we could bring Earth bacteria with us. If there is life on Mars, our bacteria could destroy it. That would make it impossible to study Mars properly. The same is true for Europa or Titan. Some scientists believe we should not send humans to these places until we are sure we will not harm anything. Another question is about space resources. Some companies want to mine asteroids. There are asteroids full of valuable metals. Others have water, which could be used to make rocket fuel. But who owns these resources? Should space mining be allowed? Some countries have already passed laws allowing companies to claim space resources, but others say space should belong to everyone. If humans colonize Mars, how will it be governed? Will Mars have its own laws? Who will be in charge? Space colonies could create new societies, but history has shown that colonization can lead to conflict. Some people worry that space exploration could repeat the mistakes of the past. Terraforming is another ethical issue. If we change Mars, it could affect any life that might exist there. Even if Mars is lifeless, some believe we should leave it untouched. Others argue that if Mars has no life, we should make it livable for humans. There are also concerns about the cost. Space exploration is expensive. Some believe we should focus on solving problems on Earth first. Others argue that space travel could help humanity survive in the long run. If Earth faces a disaster, having humans on other planets could ensure survival. Despite these challenges, human exploration will continue. NASA, SpaceX, and other organizations are working on new technology. The Artemis program plans to send people to the moon. This will help prepare for Mars missions. SpaceX is developing Starship, a rocket designed for deep space travel. In the future, we may see humans walking on Mars. Beyond Mars, human space travel is still a dream, but new discoveries and better technology could make it possible. In 100 years, humans might live in space cities or on other planets. The solar system is full of possibilities. The future is uncertain, but one thing is clear: human curiosity will keep pushing us forward. Theories and mysteries of the solar system. The solar system is full of mysteries. Scientists have discovered a lot about how it formed and how it works, but many questions remain unanswered. Some theories try to explain strange observations. Others try to solve puzzles about the past. New discoveries continue to change what we know. Some of the most interesting ideas involve hidden planets, wandering worlds, and violent events in history. One of the biggest mysteries is whether there is a hidden planet in the solar system. Scientists believe there might be a ninth planet far beyond Neptune. This idea is called the Planet 9 hypothesis. It started when astronomers noticed something strange. Small, icy objects beyond Neptune were moving in unusual ways. Their orbits were not random. Instead, they seemed to be pulled in a certain direction. The best explanation was that a large planet was affecting them. Scientists believe Planet 9, if it exists, is much bigger than Earth. It could be 5 to 10 times Earth's mass, but it is very far away. It might take 10,000 to 20,000 years to complete one orbit around the Sun. Because it is so distant and dark, no one has seen it yet. Astronomers are searching for Planet 9. They use powerful telescopes to scan the sky. But finding a planet that far away is not easy. Some scientists think it may not exist at all. Instead, the strange orbits of the distant objects might be caused by something else. A group of smaller objects or even a black hole could explain the same effects. The mystery remains unsolved. If Planet 9 is found, it will change our understanding of the solar system. The planets in the solar system are not in their original positions. They moved around in the past. This idea is called planetary migration. Scientists believe Jupiter and Saturn played the biggest role in this movement. A theory called the Grand Tack model tries to explain how the early solar system evolved. According to this model, Jupiter was the first planet to form. At first it moved inward, closer to the Sun. As it moved, it disrupted the material around it. It may have prevented super-Earth-sized planets from forming near the Sun. When Saturn formed, its gravity affected Jupiter's movement. The two planets pulled on each other, changing their orbits. Eventually, they moved outward to their current positions. This movement explains some strange features of the solar system. The inner planets, like Earth and Mars, are smaller than expected. In other star systems, super-Earths are common. But in our solar system, they do not exist. The Grand Tack model suggests Jupiter's early movement cleared out material that could have formed bigger planets. Planetary migration also helps explain why Neptune and Uranus ended up where they are. Some scientists believe they originally formed closer to the Sun. As Jupiter and Saturn moved, they pushed Neptune and Uranus outward. This process could explain why the outer solar system looks the way it does today. Another mystery in the solar system's history is the late heavy bombardment. This was a time when many asteroids and comets crashed into planets and moons. It happened about 4 billion years ago. Scientists believe the Moon, Earth, Mars, and other planets were hit by countless impacts. Some of these impacts were large enough to change entire landscapes. Scientists discovered this event by studying the Moon. Apollo astronauts brought back lunar rocks. When scientists examined them, they found evidence of massive impacts. Many of these impacts seemed to happen around the same time. This suggested there was a period when collisions were much more common than today. The cause of the late heavy bombardment is still debated. Some scientists think it was triggered by planetary migration. If Jupiter and Saturn changed their orbits, they could have disturbed the asteroid belt. This would have sent a wave of asteroids toward the inner solar system. Others believe that interactions between planets and leftover material from formation played a role. This period had a big impact on Earth. Some of the impacts could have created deep craters and even affected early life. Some scientists think asteroid impacts may have delivered water to Earth. Others believe that extreme impacts could have wiped out early life forms, forcing life to restart. The late heavy bombardment may not have been a single event. Some evidence suggests that impacts continued at different times. Future research could help scientists understand exactly what happened. Studying other planets and moons can reveal more clues. Even with all these theories, the solar system still holds many secrets. Scientists continue to search for hidden planets, study planetary movement, and investigate the history of impacts. New telescopes and space missions will help answer some of these questions, but some mysteries may take a long time to solve. The more we learn, the more we realize how much there is still to discover. The solar system is always changing. It may seem stable now, but over millions and billions of years, it will transform. The biggest change will come from the sun. The sun is the center of the solar system, and its fate will decide the fate of everything else. Planets, moons, asteroids, and even life on Earth will be affected. Scientists have studied the life cycle of stars like the sun. They have predicted what will happen. The future of the solar system is written in the stars. Have you ever wondered how the sun will change over time? The sun is a giant ball of hot gas. It burns hydrogen in its core to produce energy. This process creates the heat and light that make life possible on Earth. But the sun will not shine forever. It is using up its fuel. Right now, it is about 4.6 billion years old. Scientists estimate it will last for about 10 billion years in total. That means it is middle-aged. It still has about 5 billion years left before it changes completely. As the sun ages, it will get brighter. In the next few 100 million years, it will slowly heat up. This will affect Earth. Temperatures will rise, oceans will evaporate, life will struggle to survive. In about 1 billion years, Earth may become too hot for most life forms. In 5 billion years, the sun will run out of hydrogen in its core. It will then start burning helium. This will cause it to expand. It will become a red giant. A red giant is much larger than the sun we see today. The sun's outer layers will spread out. It will grow so big that it may swallow Mercury and Venus. Some scientists believe Earth could also be swallowed. If not, it will be burned by the sun's heat. The sky will turn red. The sun will take up a huge part of the sky. During this time, the outer planets like Jupiter and Saturn will not be affected as much. They are far enough away to survive, but their moons may experience changes. Some moons with ice, like Europa and Enceladus, may briefly warm up. This could cause their frozen oceans to melt, but this will not last. After a few million years as a red giant, the sun will lose its outer layers. It will shrink and become a white dwarf. A white dwarf is a small, dense star. It is what remains when a star like the sun dies. It will no longer produce energy in the same way. Instead, it will slowly cool over billions of years. The solar system will look very different. The inner planets will be gone. The sun will be a tiny white dwarf surrounded by the remains of its past. The outer planets may still exist, but they will be cold and lifeless. The sun will no longer shine brightly. It will be a fading ember of its former self. Now let's discuss about the eventual fate of the planets. The inner planets, Mercury, Venus, and possibly Earth, will be destroyed. The sun's expansion will either burn them or swallow them completely. Mars may survive, but it will be dry and lifeless. Jupiter and Saturn will likely remain. Their moons, however, will change. Many moons, like Titan and Europa, have thick atmospheres or icy surfaces. As the sun becomes a red giant, the heat could melt their ice. But once the sun becomes a white dwarf, they will freeze again. These worlds may become cold and inactive. Uranus and Neptune, the ice giants, will also remain. They are far from the sun, so they will not be destroyed, but without the sun's warmth, they will become even colder. Their atmospheres may change over time. The Kuiper Belt and Oort cloud, which contain comets and icy bodies, will also survive. However, without the sun's strong gravity, some objects may drift away into space. The solar system will not be the same. Over time, the planets may slowly move outward. The sun's gravity will weaken as it loses mass. This could cause the orbits of planets to shift. Some planets or moons might even be thrown out of the solar system entirely. They could become rogue planets, drifting alone in space. Will humanity colonize other planets? Earth has been the home of life for billions of years, but it may not always be safe. If humans survive long enough, they will need to leave Earth. Scientists have thought about this for years. If we want to survive in the far future, we must colonize other planets. Mars is the first option. It is the closest planet that could support human life, but it is not easy. Mars is cold and has a thin atmosphere. It does not have liquid water on the surface. To live there, humans would need shelters, water supplies, and ways to grow food. Some scientists believe we could terraform Mars. This means changing it to be more like Earth. We could heat the planet and create a thicker atmosphere. But this would take hundreds or thousands of years. Jupiter's moon Europa is another option. It has a deep ocean beneath its ice. If humans could build underwater cities, they might survive there. Titan, Saturn's largest moon, also has an atmosphere. It is cold, but with the right technology, humans could live there. Beyond our solar system, there are exoplanets. These are planets that orbit other stars. Some exoplanets may be Earth-like. If humans develop advanced space travel, they might be able to reach these distant worlds. This would take centuries or longer, but it could be humanity's best chance for survival. There are many challenges. Space is dangerous. Radiation, microgravity, and lack of resources make it difficult. But if humans find solutions, they could spread beyond Earth. They could become a multi-planet species. Let's talk about how our solar system will end. Nothing lasts forever. Even after the sun becomes a white dwarf, the solar system will continue to change. Over billions of years, the planets may drift away. Some may collide, others may be pulled into the sun. The sun itself will continue to cool. Eventually, it will become a black dwarf, a cold, dark remnant. If the solar system survives long enough, it may face a final challenge. The Milky Way galaxy is on a collision course with the Andromeda galaxy. This will happen in about 4.5 billion years. The collision will reshape both galaxies. Some stars will be thrown out, others will form new star systems. The solar system could be affected. The sun might be flung into deep space, or it could become part of a new galaxy. By then, humans may not be around to see it. Or, if they have advanced enough, they may live among the stars. They may look back at the solar system as their ancient home. The future of the solar system is full of change. The sun will grow, then shrink. Planets will be destroyed or drift away. The solar system will not last forever, but for now it is our home. Scientists study these changes to understand what will happen. And as humans explore space, they may one day find a new home beyond the solar system. The universe is vast and the future is full of possibilities.